Okay, we're going to skip section 4.8, and 4.8 is a nice application of the derivative. You can read about it if you want, but 4.9 is the last section in the chapter and is really just kind of an introduction into things that we'll be doing for the rest of the course, which is antiderivatives. When you study calculus, you study, really there's three major topics. There's limits, derivatives, and antiderivatives, or integration is sometimes another term that we'll use for antiderivatives. So here's a definition. It says that a function f is an antiderivative of little f if f prime of x is equal to little f of x for all x. Okay, so let's take a look at some examples. Suppose that f prime of x is equal to x cubed minus 5. Okay, an antiderivative is a function whose derivative gives you, in this case, x cubed minus 5. Okay, well, if I had x to the fourth, and I use the power rule, I know that the power of 4 is going to come down and reduce the power by 1, right? I get 4x cubed. Now I don't have a 4x cubed, I get an x cubed. There'd be a 4 in front. So to offset that 4 that would be coming down from the power rule, I would want to divide by 4. Okay? Minus the derivative of 5x would be a minus 5. Now, here's the thing. In my answer, I've got a plus c. C is a constant. And we know that the derivative of a constant is always 0. Okay? We sometimes call this the general antiderivative. Okay, we'll talk about what's called a particular antiderivative shortly, but a general antiderivative is really just a kind of a general case, okay, where you differentiate a constant and you get 0. Okay. It doesn't matter what the constant is. You know, the constant could be 3 or negative 8 or whatever. Okay, so there would be lots of different expressions whose derivative would be x cubed minus 5 because this constant can take on infinitely many values. Be sure that you write the plus c in the case of finding a general antiderivative. That is something that students will forget about on occasion. Okay, and make sure that you remember to do that. Now, the nice thing about an antiderivative is that you will always know if you have the right answer. Okay? Derivatives are going to be kind of phased out a bit now as we get into this third topic, but not completely. Because in order to check if you have the right answer, you can take a derivative, and that should get you to the previous expression that you had started off with there. So like in this case, if I were to differentiate 1/4 x to the fourth minus 5x plus a constant, well, I'd use the power rule, right? The 4 would come down, it's going to cancel with the 4 down under, and you'll have x cubed minus 5 plus 0. Okay, so it's still important that we know our differentiation rules. We will use those to check our answers, okay, but we are kind of leading into a new topic here of antiderivatives. Here's another example. Okay, suppose that f prime of x is equal to the square root of x plus the cubed root of x. What is the antiderivative? Okay, so what is a function whose derivative is the square root of x plus the cubed root of x? Well, the square root of x, that's the same as x to the 1/2. If I had x to the 3/2, then using the power rule, I know that 3/2 would come down in front, and I'd reduce the power by 1. That would give me 3/2 x to the 1/2, right? But to offset that 3/2 that would be coming down from the power rule, I'd want to make sure that I divide by 3/2. Now, dividing by 3/2 is the same as multiplying by 2/3. Okay, so then on the other term here, the cubed root of x, that's the same as x to the 1/3. Well, if I had x to the 4/3 and I use the power rule, the 4/3 would come down, and I'd reduce the power by 1. That'd be 4/3 x to the 1/3, right? Now to offset that 4/3 that would be coming down in front from the power rule, I'd want to divide by 4/3. Dividing by 4/3, though, is the same as multiplying by 3/4. We're looking for the general antiderivative, so I need to make sure I add a plus c at the end. Okay, and I can check by differentiating. Okay, the derivative of 2/3 x to the 3/2, that'd be 3/2 times 2/3 is 1 times x to the 1/2, or the square root of x, plus it's going to be 3/4 times 4/3 is 1 times x to the 1/3, that'd be the cubed root of x, plus the derivative of a constant is always 0. Okay. By the way, sometimes I'm going to use the term reverse power rule. Okay, when you find an antiderivative using the reverse power rule, all you're doing is you're adding 1 to the power and dividing by that new power. That's all I did here to get the x to the 4th over 4. That's all I'm doing with these two terms. I'm adding 1 to the power and then dividing by the new power there. Okay. Here's another example. Okay, f prime of x equals 6e to the x plus sine x. What is the antiderivative? Well, derivative of e to the x is itself e to the x, so the antiderivative of e to the x would be itself e to the x, right? 6e to the x would be the first term there, and then I know the derivative of cosine x is negative sine x. Because there'd be a negative, I'd want a negative here. So it'd be a minus negative sine x, would give me the plus sine x when I differentiate, plus a constant. Okay, and now recall from chapter 3, I have my notes here from, this is in section 3.6, if you were to flip back. So there was a theorem, the derivative of the ln of the absolute value of x is 1 over x. Okay, and we looked at 1 or 2 examples of that. I have restated that here. Okay, so the derivative of the ln of the absolute value of x is 1 over x. Therefore, the antiderivative of 1 over x would be the ln of the absolute value of x. Okay, what is the antiderivative of 1 over 1 plus x squared? Well, again, it is so important that we remember our differentiation rules, okay? Because, another way to ask this is, what function has a derivative that is 1 over 1 plus x squared? Well, that'd be tangent inverse of x. The derivative of tangent inverse of x is 1 over 1 plus x squared. Okay. Derivative of a constant is always 0. Okay, so my answer, the antiderivative of this expression, would be f of x equal the ln of the absolute value of x plus tangent inverse of x plus a constant. Now, be sure that you include the absolute value bars, okay? That's a necessary thing, because if x can be any number, we know we can't take ln of a negative. We also know we can't take ln of 0, but it's understood that x can't be 0 initially there with we can't divide by 0. Okay, here's another example. F prime of x is 5 minus 4x cubed plus 2x to the 5th all over x to the 6th. What is the antiderivative? Okay, so, we looked at the quotient rule in a lot, when we were working with derivatives there, but there is no reverse quotient rule, okay? Now the best thing to do here, and we've done this a ton, in the case of derivatives, like we saw many different times that before you take a derivative, you might want to consider simplifying and then differentiate. Same thing with antiderivatives. Like before you just jump right to an antiderivative, sometimes you might want to simplify and then take an antiderivative. Okay, so let's consider that here. If I were to split this single fraction into 3 fractions, I've done that on the next line. And then I'm going to rewrite these terms so that I can apply the reverse power rule on the first 2. Now I'm ready to go to the antiderivative. The antiderivative of 5x to the negative 6th, well, I'd leave the 5 alone. Now remember, constants can come out of derivatives. Therefore, constants can come out of antiderivatives. Okay, so this 5, that's a constant. I would just leave that alone. The antiderivative of x to the negative 6, that'd be x to the negative 5th divided by negative 5. I'm using the reverse power rule. Minus 4, I'll leave that as is, times x to the negative 2nd divided by negative 2. Again, add 1 to the power, divide by the new power. Plus antiderivative of 2 over x, well, 2 is a constant, right? And the antiderivative of 1 over x is the ln to the absolute value of x. Plus c. Again, don't forget about the plus c. Okay, students will sometimes forget about that, and I will take a point off if you don't remember that. Okay, because if you don't have the plus c there, it's understood that c is 0, and we'll talk about a particular antiderivative later. But c can be any constant, okay, not just 0. So we have to make sure that we have the plus c there. Okay, usually we don't want to give our answers with negative exponents, just like as was the case with derivatives. So okay, the 5s are going to cancel there. You're going to have negative 1 over x to the 5th, and then plus 4 over 2 is 2, divided by x squared, and then plus 2 ln of the absolute value of x, plus a constant. Okay, here's another one. F prime of t equal cosine t minus 3 times hyperbolic cosine of t. Well, I know the derivative of sine t is cosine t, and I also know that the derivative of hyperbolic sine t is hyperbolic cosine t. So my answer would be sine t minus 3 times hyperbolic sine t plus c. Okay, here's another one. F prime of theta equals secant theta times the quantity secant theta plus 1/2 tan theta. Well, let me distribute secant theta into these two terms, and then I can get the antiderivative. So I'm looking at secant squared theta plus 1/2 secant theta tangent theta. I know that the derivative of tangent theta is secant squared theta plus 1/2, that's a constant, I'll just leave that alone. And I know that the derivative of secant theta is secant theta tangent theta. And then plus a constant there at the end. Okay, so again, derivatives are not going away completely. We still have to know that stuff, but you know, this is a new topic though. Okay, let's take a look at another example. Find f of x if f prime of x is x plus 1 over x cubed, and x is greater than 0 and f of 1 is 6. All right, well, let's start by getting the general antiderivative, and then we'll use this information at the end, f of 1 equals 6. F of x, you'd want to use the reverse power rule on these two terms. Okay, so you're going to add 1 to the power and divide by the new power. Okay, the antiderivative of x would be x squared over 2, plus the antiderivative of x to the negative 3rd, that'd be x to the negative 2nd divided by negative 2. Again, you're adding 1 to the power and dividing by the new power. Now, a mistake that I will see students make on occasion is that they'll be subtracting 1 from the power. They get mixed up with derivatives. Don't do that. Okay, it's the reverse power rule. Okay, you're going to add 1 to the power, divide by that new power. And then, of course, we want a plus c at the end. This middle term I can rewrite as a minus 1 over 2x squared. Now, f of 1 equals 6 means that for this particular problem, there's going to be only one answer. There's not going to be infinitely many like I was doing over here with this plus c, since c can be infinitely many, constants. I'm going to get a specific answer. And I can find that c value by plugging 1 into the function that I've created here. F of 1 would be 1/2 minus 1/2 plus c, or that would be c. F of 1 is 6. Okay, so c would be 6. My answer then would be what I have here, but just c is 6. F of x is 1/2 x squared minus 1 over 2 times x squared plus 6. Okay, and we call this a particular antiderivative. A particular antiderivative just means that there's only going to be one answer. C is a particular number. A general antiderivative means that you're just looking for kind of like a general form, and there's, C can be any constant. All right. Now, more times than not, we are going to be working with a general antiderivative. Okay, but there is on occasion situations where we're going to find a particular antiderivative, and so all that means again is that they'll want you to find the particular number for the constant there at the end.